you for 9 speakers preceding me, and I can stand on your shoulders. In fact, not only you guys, 9 people, but exactly 65 years ago, 1956, the people from East and West gathered to discuss about atoms for peace, as you know, right? In which fusion was declassified. A collective accelerator idea from Budka Institute, Wexler, discussed about plasma-based accelerator, very compact, or should have been a very compact accelerator. Instead of $100 billion, 100-kilometer size accelerator, maybe on your palm top. That was the visions and the aspirations which have been discussed 65 years ago in Geneva. Here we again, East meets West, but this time to tackle global energy crisis that you guys, 9 speakers have spoken about. And it is very urgent. So that's what I would like to contribute to. Okay, so how do I go? Yeah. So even myself, to the right of this picture is my 1 block away from my house, which was devastated by the very dry and hot weather in Southern California, October fire. This was because of the western part of the continent. In this case, North America continent is very dry and hot, whereas the east part of the continent, such as the eastern part of the Europe and Asia continent, opposite happens, very dry and very drenching rain and also warm weather, which causes like a flood. And in this conference, the northern part of the continent suffers the melting of a tundra and associated troubles. So these are already manifesting in our own daily life. In my case, I have to be mandatorily evacuated from my house to avoid this fire due to the very dry and hot weather in California. So here I would like to make a few examples of how we can cope with this crisis. First one is I'm going to recapitulate that Michael Bindawar was discussed about a fusion by a neutronic path that my mentor, as well as his mentor, Professor Norman Rostoker, followed this declassified fusion since 1956. Second item is the kind of thing that's similar to what Stepan already talked about, what I called characterize to institute a toilet in nuclear energy. Toilet, in this case, you generate radioactive nuclear waste, but we usually do not care about too much. Only you care about energy production, which is the forward side of the science. That's like a kitchen instead of toilet. Toilet is left out, but we now have to address our toilet of the nuclear energy. So that's what I'm addressing. Some of the speakers have already spoken, nuclear transmutation. Third item is again the brainchild of 1956 by Wexler from Budka, who advocated the plasma-based accelerator, collective accelerator, which I also followed his inspiration. And then also I would like to follow by looking at the tall trees in California. Well, the tallest tree happened to be in California. So this I call the bio-inspiration in nuclear energy. Okay, I'm going to make an artificial tree, which is driven by nuclear energy. So these are some of the outline that we can think about it. As Michael Bindawar talked about, based on the declassified fusion research in 1956, well, okay, some of you also mentioned the fusion is always 30 years away from now. But if you do, like Norman Rostoker mentioned, end in mind research, and also a neutronic type of fusion, it can compress the research length by large amount. And it has certain new ideas, which I call the bicycle-like stabilization. Bicycle is unstable if you don't pedal, but if you pedal sufficiently hard enough, this kind of left or right falling to appropriate indefinite length of the riding on the bicycle, right? So this is the kind of technology that we are now witnessing that you can create by a relatively simple geometry, as Michael Vinderberg mentioned, but driven by the particle, high energy particles. High energy particle can do two things. One is that because the energy is high by accelerated particle such as 100 keV or slightly less than 100 keV, you can make energy already high enough to cause the fusion without worry about too much of heating. Other thing is that also it will, like a bicycle tire, to make a spinning bicycle tire to be stable as a plasma stabilizer. So these are the new ideas, and then also embedded in pioneers such as Norman Rostoker, and then we are realizing it very fast because the beam is available and you don't have to go by heating up a long time. Okay, so that's the one idea already talked about. I don't have to go deeper than that. Second idea we can utilize to address our crisis is to institute a toilet to nuclear energy, which I mentioned already to an extent. And then the Stepan and then Lee have mentioned also already. So instead of a kitchen side of the nuclear energy only, we have to take care of a toilet side of the nuclear energy, which is the transmutating, specifically damaging high, long-lived nuclear waste. And that can be done by high energy neutrons presence. High energy neutrons can be created once again, as some of you already mentioned, Stepan in particular. You can utilize nuclear reactions. Usually people think about using nuclear reactors, nuclear reactions, but we can drive the beam, and beam-driven fusion, low energy beam is sufficient to trigger the fusion-based neutrons. So these are the new science in 21st century, parting from 20th century science like Einstein here, who have done the great science push in the kitchen side of the science. But now we need to take care of the toilet side of the science as well. So we are going to do the toilet science of this, such as this kind of deep burial facility on Kalo in Finland to become much safer and long-lasting, and then ensuring the safety and the reduction of the toxicity. This picture has been mentioned at least 3 times by now, so I'm going to skip, but how you can reduce the toxicity and the volume of this by 100 to 1,000 times by transmutation, right? So I have to skip that. Main important part of the relatively energetic neutrons, which some of you mentioned, such as Stepan, is that this diagram, for example, if the neutron energy is greater than MeV, which is a 10 to the 0 MeV here, then the neutron has a specific fission-driven capability over absorption of the neutrons. So that's why we needed some presence of energetic neutrons to maintain the transmutation in the proper direction. If you do that by fusion, the Allen mentioned that you can make a cheap laser, efficient laser conversion of accelerating deuterons into a beam of 100 keV. 100 keV deuteron beam can cause the copious 14 MeV neutrons, order of 100 times energy catapulting, and this can cause 200 MeV fission. So you get this kind of energy catapulting that will cause the reduction of the expensive accelerator-driven neutron production. I'm not going to the detail of this because I think we don't want to spend too much time in the details. And some of you, like Stepan's talk, have already mentioned about the plutonium importance and then how to kill the americium, neptunium, and curium, etc. So we don't go into the detail of this, how we want to reduce some of the minor actinide by the neutron, high energy side of the neutrons coming from fusion, for example. And then they try to reduce or take out the fission products so that you don't get stopping of the fission products of the transmutation. So these are some of the technical challenges we have to address in order to make a transmutation process to go forward. So which we did studied, as Alan also mentioned kindly. Okay, so we have invented a certain operation stand, which is what I call the go liquid. Instead of solid-based fission reactor concept, which is what Enrico Fermi in 1940s started, and because of his rapid success in only 4 years in the Chicago pile, what is I call the technology collapse happened. In other words, all the nuclear engineering has to be like what Enrico Fermi did. That is a solid operational engineering of the nuclear reactors. But there is a way to make a liquid operation, such as molten salt. And if you do that in operation in liquid, you have a much more amenable way to operate in a safe way and avoid what Lee said, the runaway operation. Avoid the runaway operation because the molten salt is a liquid. So if you have begin to chain react, liquid will automatically expand and then they go down below critical, etc., etc. There are just not one. There are many other operational embedded safety functions by go liquid. Other liquid property is the laser can penetrate through and you can measure or you can monitor the reactions in less than nanosecond type of time scale. And also we can make a very compact neutron source by penetrating inside and then you get creation of the neutron in situ in a very, very tiny way. So you have not just one neutron source, but thousands of neutron sources by thousands of fiber laser injection, et cetera, okay? I don't go into the detail. And it also because of this time scales are now compressed between the mechanical types of injection or takeout of the created fission products and the input of the fuel. And on the other hand, the nuclear reaction, which is this much faster timescale. These are disparate timescales, which are now can be converged into the common timescales because of the liquid operation. These are some highly technical points. I don't go into the details, but which allows us to make a monitor and feedback control to be realistic. As Bindabauer mentioned, AI control is very important in the nuclear engineering. And this convergence of two timescales, of the mechanical timescale on one hand and the nuclear timescale on the other, now begins to become overlapping. And if you do have overlapping, then you have a monitor and feedback control through AI adoption. So we are beginning to demonstrate that kind of thing in one example here. Again, I don't have time to demonstrate to you how to do it, but this is one example of how we can make instituting feedback control mechanism through AI so that you don't have any runaway or any disruptive operational dangers by this kind of nuclear technology. Okay, so last 2 points, I have to go quickly. Collective accelerator is one of the very cardinal, interesting idea and inspiration came out of 1956 Wexler's talk at the Geneva, the same thing. And this one made Norman Rostoker to work on the collective accelerator and compactifying it. And Dawson and I happened to come with the laser accelerator, which Alan mentioned. And this can make this kind of huge accelerator to be on your palm size, which is being structured into the research in Alan's labs. So using this, well, this is again Alan mentioned about some of the Hungarian. In this particular case, the left is the Hungarian president, got interested in this type of research. So we are beginning to work with them at Eli Alps. Again, I don't go into the details, but we are able to demonstrate this kind of laser in a very compact, small, millijoule operation, have a 75% efficiency from laser to the deuterium ions. This is just artificial simulation showing nanometric foil creating millimeter target in a millijoule type of operation. And you can make thousands of that in one such a transmutator. So that subject I'd like to mention is to learn from our biosphere. You may call it the bio-inspired nuclear energy, or we will try to create artificial tree. How do we do that? Well, if we try to make a carbon negative, some of you mentioned that it's not enough to be carbon neutral because ice melting process is so slow that we may have to go negative. Okay, if we do, well, one thing is that like learning from the tree. Tree is, of course, absorbing CO2 and the return to the oxygen, right? So if we try to learn from the tree, this is the highest tree in the world, Sequoia tree in California, well, we can get the inspiration of how can we make a tree-like way of nuclear energy operation. First of all, nanotube can pump the water more than 10 meters. This is more than 10 meters high without any pumping operation. You don't need to provide any pumping because it's the surface tension of the nanotube will pump the water up more than 10 meters without a problem. Permit thin film of nanotube in the leaves can permit the photons penetrate to make a chemistry. So if we can make artificial tree in carbon nanotubes with the adjacent to the radiation abundant nuclear reactors such as the fusion reactors or transmutator, based on these giants like Ryogo Kubo or Ilya Prigozhin, on the bunch of material scientist giants, we can design artificial tree for nuclear energy or toilet of nuclear energy. So some of the ideas, I don't think I have too much time, but there are lots of carbon-based walls, such as graphene or carbon nanotubes. Heat transport efficiency is very, very high. Heat conductivity is extremely high, in fact, higher than the metal. Strength is very, very strong than metal in the direction of tensile. Bending is very flexible, on the other hand. Newton damage is the least. Chemical corrosion is the least. Replaceability, safety, and etc. So this is one of those graphs. I don't have time to explain to you, but we can compare the metallic materials with the carbon materials. Very different in a good way. This is another table I don't have time to go through, but again, metal versus carbon-based material. Many of the Newton damage, Newton activation, corrosion, chemical corrosion, and physical property, orders of magnitude superior. Why do they not use these materials? I don't understand it. Well, I guess I understand it. The metals are easy to make, and our civilization 20 centuries ago or 40 centuries ago discovered the metal first. Again, the technology collapsed to the metal. But now we know the carbon technology, or we get the bio-inspirations, right? So bio-inspired wall has very abundant, interesting features, which you might try to make fusion reactors more safe or more realistic, or you can go carbon negative from this transmutator or carbon fusion reactors. So these are some of the benefits by going a bio-inspired wall. So in summary, I hope I went very fast, but nonetheless, try to take a spirit of 75 years ago of our fathers or grandfathers who met East and West and Geneva to start atoms for peace. Now we are talking about science for global warming crisis solution. Also, it was 65 years ago, the collective accelerations suggested. We now reap this kind of ideas finally materialized, such as Alan mentioned, in Irvine, in a very, very convincing ways, and making an accelerator of the GV in the centimeter instead of 100 meters, etc. GV proton accelerator hundreds again meters to make a transmutator. Now we get millimeter, etc. So we get this 65 years of the previous predecessors. We are now standing their shoulders to address even higher, or graver crisis. In neutronic fusion, Tourette science for nuclear energy, compact neutron source to drive neutrons from the fusion by efficient laser-driven acceleration, bio-inspiration to make such reactors like fusion or transmutator to be compact, not only compact, but we shall find a path toward carbon negativity utilizing these radiations coming out of the fusion reactors or bio-inspired transmutator interior radiations to trigger, to make CO2 or methane to be decomposed into something less damaging to our environment, or convert collected CO2 from your chimneys into something safer. So these are some of the artificial trees we can construct based on the bio-inspirations. Thank you very much.